I'm Ed from Moneybox. I run our product engineering group, so essentially anything that involves getting technology to our customers. Hopefully, a few of you, most of you have heard of Moneybox, but we're a UK-based fintech, around about 10 years old, give or take. And our goal really is to help people save and invest their money for good outcomes for the long term. So we do offer stock trading and things like that, but only in a long-term basis. The goal is that people will benefit from the kind of investments and savings approaches that will help them get what they want from life, whether that's a house purchase, holiday, retirement, whatever it is, whatever life stage, we're trying to help with those kind of things. It's been a good journey so far. Like, we're up to actually over 1.5 million users, but 1 million customers who are active on the platform. And that adds up to over £15 billion of their money that we look after, or money and assets. And it means also the platform is very busy. So we get something like 20 million API calls daily. And at peak periods, we've had something around 40 logins a second. And this is all in quite a critical regulated environment. So we play a crucial part in people's lives. If our service isn't available when they need the money to pay their house deposit, they don't complete on the day. If our service isn't available when they need to withdraw from their savings account in order to pay a bill or whatever, they're stuffed, we're stuffed. So we have to be very, very good, very strict, very available in the service. It needs to be reliable. So I'm going to talk a little bit about that. But I guess the first thing I was going to say is, despite my obvious youthful vigor, cool vibes, all of that kind of thing, I'm actually pretty old. So for the 10 years or so before joining Moneybox, I was a big company guy. So chief architect, CTO, an enterprise software vendor, selling stuff into government, local government, public sector, all of those kind of things. So big company mindset and big company solutions, big company problems. So my plan when joining Moneybox around about 2019 was to see if I could combine those two worlds. So join a small growing company, get a little bit back closer to the technology, get more hands-on, but also see what of my experiences in the big company world would be helpful in that environment. And that's what happened, right? So when I joined, there were about 3 people on the team. So by necessity, I had to get hands-on, actually doing some programming, building some key features, putting in place some foundational systems stuff in order to help us grow. In the intervening years, we've grown a lot. So there's something like 75 people in my group. And I hardly ever get hands-on with the code these days. But I do still obviously pay attention to what's going on. And what happens quite a lot at our team meetings is the team will talk about some work they've done, which is great. But sadly for me, a lot of those talks have the same agenda, which is, 1, you know that thing Ed built? Here's why we all hate working with it, and here's why it's bad. And here's my much better solution for how we should do it going forward. Luckily, though, Terraform was one of my babies. I introduced that in 2019 when I joined, and that's still around in the company today. Sadly for me, here's the agenda. So, actually, let me professionalize this a little bit. So I'm going to talk a little bit about our journey with Terraform. I appreciate there's a lot of different types of organization in the audience, so I'll also oscillate wildly between organizational direction, architecture, and hands-on detail to try and give everyone a little bit of something, or at least to disappoint everyone equally. So first of all, a bit of context from Moneybox. We've got a very strong focus on doing things simple, direct for the customer. So trying to move anything that isn't directly delivering value to us in the business out of the way so we can get on with keeping things moving, doing things better, and adding value. So that means we are heavily platform as a service first. We really don't like managing infrastructure. We're very focused on the Azure cloud. We're not trying to manage a hybrid cloud or a multi-cloud. We're trying to let Microsoft do as much of the heavy lifting for us as possible. And so we lean into the features and capabilities of the platform. We combine a few other suppliers in the mix, like Cloudflare, Datadog, and Terraform, particularly via Terraform Cloud these days. And because the company was born in the cloud, we're zero trust, so we don't have a corporate network. We started from that position, right? It's a similar story for our software. So we favor big systems that allow us to do things simply directly for customers. So we try and avoid all of the distributed systems problems. We are a one product company, right? So we've got that going in our favor. There's essentially two large infrastructure teams, one front of house, one back of house. Software development teams. And we build things in these large blocks so that everything that team needs to do is under their control, strongly typed, easy to change, easy to test, all of those things. And we deliver multiple times a day, 10, 20 times with zero downtime. Initially as well, we didn't have any technology ops teams, 100% DevOps. Today, we've got a very small operations team called Team Thunder. Less than 5% of the engineering resource in the organization. And in fact, 2 of them are here today, which is kind of a risk, given how many are left back at base. But let's hope they don't both go on that boat trip later on. But their role is not to manage the technology. They're to kind of guide and set the standards, but we want everyone to be in charge of their own technology, their own infrastructure, looking after the live service, caring about customers. So Team Thunder is focused on these outcomes. The engineering team is focused on making it happen. So Terraform, as I said, I introduced it in 2019. It was kind of an engineer-led adoption. It was cool and fun and interesting. Like, the declarative style is unusual, and it's fun getting your head around it if you're used to more imperative or procedural programming styles. And we just needed it. We were getting to the point where we couldn't have, as we were getting more people hired, we couldn't have everyone clicking their way around the Azure portal and trying to recreate more and more complicated systems across 4 or 5 different environments. So it was kind of a bottom-up adoption. It just seemed like the right tool. It was working. It was fun to use. It was good. In those early days, it was also super easy to get going with it. And that's one of the real strengths we found of Terraform. So we could use Terraform for our new stuff, and our existing resources, we had a load of choice. We could leave them being manually created, or we could import them into our Terraform world, or we could just pull data from them using Terraform data sources. The other thing that was great, we didn't need to change any of our other suppliers. We didn't need to switch to using Vault or Boundary. Well, I guess Boundary didn't exist, but we didn't have to move away from where we already were. The providers and the rich provider ecosystem worked really well. So initially, we were all Terraform open source, and it was fun and cool. Like, we built our own pipelines, lots of exciting terminal windows with lots of characters flying by and all this stuff. But we did it ourselves, and it worked fine, got us going. But over the years, that's become a burden. So my recommendation these days is just don't do it. If you need to move beyond running Terraform Plan and Apply on a developer laptop or an engineer's laptop, just use Terraform Cloud. It works. It's great. It's much better than the scripts we poured loads of effort into. Our architecture initially in this time period was very much focused around how we treated our software architecture, right? We wanted everything you needed to do your job in one place. So we had one big repo with all of the stuff in there. We only had really 2 Terraform routes, which are kind of the unit of deployment here. We didn't use workspaces. So all of our test environments were in one Terraform Plan and Apply. All of our production infrastructure was in a second Terraform Plan and Apply. We did use modules, but we used them for all sorts of things, from the top level being a whole application, which then depended on like a web server component within there, which depended on a storage account module, which depended on the naming conventions module, which depended on the storage account module again for some reason. And so all of that kind of stuff was in the mix there. Over time, though, that worked well. The team did grow. We're up to 20 to 30 people in this period, and we enter our teenage years where, yeah, we're pushing forward with this stuff, but we're coming at it from a kind of company benefits, policy benefits sort of thing. We're looking to get coverage. We're looking to be able to start to answer those as the company grew and our responsibilities to the regulator grew, starting to be able to answer some of those questions about how do you control changes in your environment, things like that. So it was driven more by sort of the process overlay rather than necessarily the efficiency and the original engineering drive that got us there. Which led to quite a few challenges, right? The resulting infrastructure is good. The company's still here. It worked. We did well over the years. But managing it and the engineer experience of doing that was difficult. You've probably guessed some of this would come up, but for pipelines, because of the scope, were slow, fragile. The module structure meant everything, you had no choice but to upgrade everything all at once. You couldn't take a change in one area and apply it in another. And all of those things meant the changes, any change to the infrastructure felt pretty dangerous, because maybe your change is innocuous, but who knows what's going to blow up in someone else's area over here. And that drove us to some quite risky and bad behaviors. As I said before, we like little and often continuous delivery. And with the Terraform, we'd have warnings, errors, things in plans that people knew just to ignore that would hang around for weeks, if not months. Just not a good scene. And where those risks and that fragility came from, I guess I've talked about this a little bit through the module structure, but it was largely to do with, we kind of lost track of the fact that, yes, it is infrastructure as code, but it's infrastructure, not software. So we started out with our software architecture and thinking, OK, we'll refactor as we go, but it's super hard to refactor the infrastructure. You can type all you want in the Terraform code, but at some point, a resource is going to get destroyed, a resource is going to get created or migrated, and you've got to keep live service going while that's happening, which is a little different to some of the strategies you adopt in software. And that leads to some of the fragility as well. If that fails, you might be left in a place with a working service, or you might be left in a place with a non-working service, and you're doing scary surgery in state and resources under pressure. Again, all of that stuff then led to, we started out with a team really excited, happy to be using this stuff. They felt empowered. They could build their own technology, self-serve, as some of the other people we've been talking about this afternoon. But by sort of late 2022, that motivation was at rock bottom. No one wanted to work with Terraform, even me, and I made it. So we kind of burned that goodwill. And that led to two worlds where essentially a small group of people were the Terraform experts who could reluctantly fix stuff and unpick it, but that wasn't because it was their job. It was because they were in the right place at the wrong time, and they got stuck with that knowledge. Meanwhile, about 10 times the number of people needed to use it occasionally in that developer platform mode to get their job done, and they would get stuck, they would get scared, and they'd rely on the experts, and it just wasn't good for anyone. So what did we do about this? We started to think sort of 2023, what could and should we do? Should we do anything, or should we just live with it because, hey, the infrastructure's not changing that much? But instead, we took a step back and had a look overall, right? What outcomes are we trying to achieve for the business from any of this infrastructure? Not just what should we do to refactor Terraform, but what would a new world look like? And we came up with these kind of 5 outcomes here, and started to pull together a big program of work to deliver this. You'll notice only really the bottom 2 of those, danger of change and team productivity, are directly related to the Terraform problems we were talking about. But we've got a whole bunch of outcomes we think that Terraform can help us achieve here. And that was what we did. So we put together this big program of work. I've just put this up here because this is a list of something like 30 different design documents and decisions we made. And I put up, so Rich, who's in the audience, can feel proud because he wrote about half of these. But we decided to take on this challenge of reinventing all our infrastructure, so changing the engine while the plane was in flight. And it was vitally important, but because we knew we needed it to survive 2025, 2026, but it was rarely the most urgent thing. So we also knew it was going to be a long, thin project that we'd have to keep moving along in the background whilst the product moved on, whilst the service moved on, all of those things. And so Terraform alone wasn't why we did it, but it was a key enabler for that. And in particular, at this point, we switched to Terraform Cloud because of the complexity of what we were managing got more involved. The other thing, as I said, refactoring in place was too hard, so we had a big focus on replacing one item at a time in the new world, integrating it with the old world, and gradually moving traffic across. And that, again, it made each individual build harder, but it meant the service stayed up and working the whole time. So I think there's been some sessions and other things talking about this, but we had some tough decisions in here, and this is where we talk a little bit about conflicting priorities that a few other people have touched on as well. So we like, and our instinct is to bring things together for convenience and clarity. So it's easier to make a sandwich if everything I need is in the kitchen and the fridge, much harder if I have to go and defrost something, or even worse if I have to go to the shops to buy it. So we try and bring things together to help people do the tasks they're doing most often. But that drives us towards big workspaces, which causes some of the risk and fragility we talked about previously. So the other option is you could separate for control and robustness, so reduce challenges of people getting in each other's way, manage the shared resources and kind of extract them so they're centrally controlled, as per some of the discussions we had about standardization earlier. And those kind of things drive us towards smaller and smaller workspaces and more of them. Now, left to their own devices, people tended to add more stuff to where they lived, to their home project. So we also kind of didn't want to necessarily constrain that impulse, but just make sure that people were much clearer about where the boundaries were, where they were allowed to do that and where they weren't. So in our matured structure, we kind of broke that knot by sort of relaxing about it a little bit. So rather than trying to come up with the one structure and policy to rule them all, we just said there are kind of two worlds and there's 3 layers that go into that. So first, and where we want people to spend most of their time, is the app layer. So this is where they're trying to do something that has a customer-facing outcome. And that's where we spend most of our engineering time. We then took the things where actually, no, we do now want control of these per environment. We want these to be shared resources. We want them to build to a standardized way, and we want them to be in the control of the more infrastructure-minded people rather than the software engineers. And then this base layer, this fundamentals layer we introduced was kind of a capability of Terraform and Terraform Cloud in particular, which is the kind of meta ability to be able to, and again, I think one of the speakers touched on it before, to be able to use the infrastructure as code to commission new infrastructure as code environments and things like that. So using that foundational ground control layer enabled us to introduce more complexity, more small elements into our world without making it such that we needed a huge team to manage them. That did mean accepting some compromises, but that's kind of how we got to this point. So I think I've covered most of this already, but essentially we end up with this world. So we used to have loads and loads of modules. Now we've got about 12 that are purely vanilla building blocks. So here's how you build a storage account. Here's how you build a key vault. Here's how you build a web app, those kind of things. And they're then pulled into these different layers of increasing kind of customer nearness, and down here, much more process and indirect. So this approach, I mean, I guess it's been 6 months-ish we've been working this way, and it seems to be going well. We've accepted some complexity from this. So key here is we've gone from having 2 workspaces to having around about 90. But what that really means is the complexity of what you have to code has gone down, because we only have we have these 11 top-level app workspaces, and everything else, rather than being more and more resources in the same area, they're just a different environment we've deployed that into. Cool. The other interesting stuff here is Terraform Cloud's got some good stuff, and Terraform in general has got some good stuff about policy enforcement, module reuse, and separating our modules out. So we now have a GitHub repo per module. Meant we can take advantage of what Terraform Cloud gives us to have controlled upgrades of those modules. So we have a new standard for how web apps work. We can adopt it in one project, see how that goes, then use the Terraform Cloud tools to see what else is, where that's being used, where else has a dependency on the older version, and gradually roll that out in a much more safe, controlled, and opt-in manner rather than force push kind of manner. Does give us a bit more work, but the safety we think is worth it. Cool. Okay, so just in the mix here, a couple of other lessons learned that I think the key thing for us was that separation, that breaking things out, start thinking of it as managing our infrastructure for outcomes rather than managing it for alignment to the software. But there's another couple of points on preventing fragility in this world that we found to be pertinent. So the first is that there's more moving parts than you might think in a Terraform setup, Terraform environment. So you kind of have your code, you plan it, you apply it. But actually, what's really happening there is Terraform's generating a plan based off what it knows in your state, based on what it finds out at the time the plan is generated. And then it asks a provider to action it. But so, frequently, well, less frequently these days because they're getting better, but you get situations where the plan comes up with something that makes logical sense, but the provider can't action it. Or if the provider can action it, then actually the underlying resources have changed, or there's a glitch at the provider, or someone else in your team has changed it somewhere else, or we're in the middle of a deployment from one of our software deployment pipelines, so that resource is being swapped out in the load balancer and you accidentally reset it because your Terraform plan undoes it. So what we found was when we're, again, another factor to bear in mind when we're breaking things up, or at least thinking about our operational processes, was you need to be aware of any one of these things could go wrong, and what are you going to do about it? How are you going to safely recover, or at least make it so it fails to a safe state rather than a indeterminate or broken state? Linked to that, when we started out as well, we got very Terraform graph happy. So joining resources together. This database depends on this app service, so we need to have the app service have access credentials for the database, but the database also then needs to know the app service's IP address in order to allow access through the firewall. And now we've got a circular dependency. And it didn't really matter when we were building the first instance, because we built the database, and then we wired it up to the app service, and then we put the final thing on. But when we try and create then the staging version or the production version, our Terraform code says, just do everything one shot, and it can't, because those things, there's circular loops all over the place. So in our revised model, we've been much stricter about the kind of architectural layers. So apps can talk to each other, can depend on each other, but they have to use data sources to get it rather than direct Terraform references. So we are in control of when some information is found out. And similarly, config flows up through the layers. So it's always safe to build foundations, then the environments, then the apps, rather than getting just chucking it at Terraform and trying to let the graph resolve itself. How am I doing for time? Yeah, 2 minutes. So this is a little niche one, going straight into the code. But one of the things we learn often is that using maps when you're creating lists of things in Terraform is much more stable, robust, debuggable, and understandable than using the other methods for creating lots of things, which are lists, and then you iterate through the array of the list, or sets, where you iterate through all the values of the lists. And those generate IDs in your Terraform plans and your state that depend on various different things. And there's... I'm going to skip over this because it's pretty niche, but essentially maps work better because you can understand what's in the plan, and you have far fewer problems when you change things with resources and ripple effects and things being created and destroyed when you don't expect them to. Talk to me afterwards about that if you're interested, or some of the team, but that's a key thing we keep in mind. So, but zooming out a little bit, like I've talked about our context and why we chose to do what we do. But there's a kind of rationale in why is Moneybox like this? Why do we do this stuff? And why have we chosen to make those strict distinctions? So when I'm thinking about technology and working with technology, I kind of like to think about it in this kind of matrix. So what we're trying to do is to move most of our day-to-day work. So it's in the top right-hand corner of this kind of quadrant. So we're doing something that is simple, like so I can just get on with it without having to worry about, oh, what's the effect on the pension if I'm adding this to the savings account, all of those kind of things. And it's direct, so I'm doing something that is of value to the business or the customer, rather than I'm sort of somewhere 5 layers down the stack doing something that's going to be of value to someone who'll then use it to build something. So ideally, we'd spend all of our time there, but if you do that, things start to get over time, things start to get repetitive, start to slow down. You start to get some of the problems about extracting standards there. And there are kind of sort of 2 rules of 3 in that. I feel that, like, so shared components are kind of 3 times harder to build and maintain than single-use components. And you kind of need to have had 3 use cases for a single-use component before it makes sense to before you know enough to extract it and create a shared component from that. So what we tend to do is kind of work directly until it becomes too hard, and then only then extract things out, rather than kind of envisioning the big framework first and then using it to build stuff. Similarly, work happens in kind of 3 different ways. So ideally, and in the early days for us, it happens through people who, with ownership, with empowerment, and with motivation. So they're doing something because they think it's going to be good, they care about it, and they have what they need to do it. As we grow, obviously, you need process and control, particularly as more and more people are doing more and more things to stop them running off in other ways. So you introduce these processes over the side, which is great, gets you the control you need. But again, it's another drag factor if there's too many of them, too hard to keep them all in your head, or it's slick and it's kind of not slick enough and it's slowing people down. So at that point, then you can kind of introduce some technology into the mix to sort of push things back so that the people can get on with ownership, empowerment, and motivation rather than process and control. So that kind of leads us to what we did with our Terraform setup and our project overall. So we've got 2 ways to evolve what we're doing: introduce more process, introduce more technology, or start to pull things out of the direct world and into shared layers. So, for instance, we take some of our things around, if an app's got a common dependency on building our zero trust interface, say it's an internal staff portal the right way, let's stop everyone having to do that in their own area. Let's pull that out into a shared building block so it becomes indirect. Or if actually everyone's creating a message bus and we only want one message bus, let's pull that down so it's now a complex, interwoven, shared resource. And indeed, in some cases, like that Terraform Foundations, we went further and pulled them in both directions so that then it's kind of just part of the sea we swim in. So we try and limit how much we do that, because those components in the bottom left have a much larger blast radius if something goes wrong, and are much harder to maintain and control. But essentially what we found, and this has been true in pretty much all aspects of our technologies, we go through these cycles of pushing fast in the top right-hand corner through people doing stuff, needing to introduce a layer of process, and then starting to unpick that and go for another cycle of evolution as we pull things into technology rather than process to allow people to get back to ownership and pull out these shared artifacts into our operating environment and our developer platform. Nice. Okay, so I think that's everything I had to say to you today. Hopefully some of that's been useful, and I'll be here to report back in the future as we inevitably adopt more and more HashiCorp tools. So yeah, thanks everyone.